Welcome to the AME Food Testing Show. Today's guest, Billy Boyle, co-founder and president of operations for FAIMS Technology. FAIMS, an emerging technique for food and beverage safety. Billy Boyle is the co-founder and president of operations. Since co-founding Owlstone, Billy has been overseeing the development and implementation of the detection technology with nanotechnology foundry partners. He's also active in business development, demonstrating to partners how Owlstone technology can be used to realize a paradigm shift in detection technologies and deployment scenarios. Billy is heavily involved in the creation and realization of new technologies and intellectual property. Prior to joining Owlstone, Billy was a research associate in the Microsystems and Nanotech group at Cambridge University in the UK, that's United Kingdom or England. In an academic industry consortium, he designed and developed silicon-opto hybrid devices for next-generation telecom systems. Now, welcome with me, Billy Boyle. Billy?
Hi, Andy. Good to speak to you today.
Good to speak with you. Would you like to add anything to your introduction?
No, that's pretty much it. In the interview, hopefully will give you a bit more of a sense of where Owlstone and our technology can be used in food and beverage safety.
Wonderful. Let's start off with a fundamental question. What is FAIMS, or Field Asymmetric Ion Mobility Spectrometry?
So our technology, FAIMS, is the heart of Owlstone, our company. In essence, it is a microchip chemical detector. So if you think about the different types of detectors and spectrometers that are currently used across the food and beverage industry, you have things like GC, mass spectrometry. Our system is a bit like systems like that, except we shrunk it down to the size of a silicon microchip. So the kind of neat thing about FAIMS, as well as it being, obviously quite small on a microchip, you can quite easily reprogram it to detect lots of different compounds. So you can take this one chip, and if you're interested in detecting, contamination in the food stuff, you can program that chip just in software to look for that particular contamination. And if you want to look for a separate contamination, again, all you have to do is reprogram it in software. So it's a very powerful and flexible analytical technique that can be used across the industry.
So the FAIMS technology, Billy, is essentially a chip that you manufacture, and that it has certain parameters for the detection of certain organisms or target organisms. Is that correct?
It is. Well, it's looking more at chemicals than organisms. So it's looking at chemicals, be it raw ingredients or concentration of chemicals during the manufacture of foodstuffs. And in essence, what it's doing, if you think about trying to detect contamination or an odor, you are typically interested in a specific compound, but it's within this background matrix of other stuff. So what our device is able to do is basically filter out the target compound of interest, detect that, and ignore the background matrix, which is not of relevance for the particular analytical measurement.
Wonderful. Let me ask you a question. How does the FAIMS specificity and sensitivity compare with other technologies?
So, as I mentioned, there's a lot of other gas phase analyzers out there, and the way I kind of look at it is there's a spectrum. So you have this kind of, on the one end, you have your lab-based gold standard analyzers, so things like GC mass spec, LC mass spec. And at the other end of the spectrum, you have more simple sensors, things like electronic nodes, the types of things. So I would say FAIMS sits somewhere in the middle of that. And so it has a very high degree of sensitivity. So typically you can detect compounds down a part per billion level, which is one of the types of levels where taste and odor is working. But what our system also gives you is a high degree of selectivity. So you don't get false alarms for stuff that might be in the background matrix. You're accurately determining what is there at low levels. So I would say it's kind of sitting somewhere in the middle. But where we think there is the key advantage, with the gold standard like GC mass spec, your challenge in analysis is that has to sit in a lab somewhere, where samples are sent back to the lab for analysis on that. One of the advantages of the FAIMS technique in our instrumentation, Lone Star, is that it's a powerful analytical technique, but because it's small and because it's quite simple to use, we can deploy that directly in fields. So this technology is being used today, on the loading dock, on the factory floor, where non-specialists can take samples, run those samples, and get an immediate answer as opposed to having to wait, for the turnaround time back in the lab. So I'd say it's a combination of analytical performance with the usability and the fact that it is deployed directly on the factory floor.
Well, Billy, I was a manager at a company called Thermo Finnegan for liquid chromatography and mass spectrometry using triple quad mass spectrometry, and it's quite a specialized area requiring very specialized skill sets and personnel to run it. Does this technology require that sort of specialized skill set?
It doesn't, and I think that's what we as a company have tried to emphasize and design around. It's about trying to take analytical capability, put it in the field, and crucially make it such that it can be operated by non-specialists. So literally anyone, the kind of joke that we have internally is, if you have a thumb, you can operate this instrument, because all you're doing is pushing a button to start the analysis, and you'll get the answer at the end of it. And typically that will be red light, green lights, and a concentration reading if that's what's required.
Great. Our audience of 54,000 listeners are primarily food production, food quality, food safety, and food security managers. What kinds of food samples can the FAIMS technology be used to analyze?
Well, so the FAIMS sensor itself and instrumentation, it's a gas phase analyzer. So fundamentally, you're looking at things in the gas phase. Now, the good thing, I suppose, in food and beverage industry is a lot of what you're looking at is, the odor above particular samples. So what we will typically do is work with solid or liquid samples, and we are looking at the head space above that sample. So essentially, what is the characteristics of the smell and the compounds in the head space above the sample, and we push that into our instruments. And I would say, one of the things that we've had to work on over the years is making sure that the samples you get into the instrument is, representative of the thing that you're trying to analyze. A lot of the difficulty and the challenge in analysis of foodstuffs does come down to sample introduction. So we do work across that broad range of, liquids, solids, and obviously gases. But, the engineering expertise that we've applied has been largely around how you repeatably get that sample, from your food or beverage product into the instrument, so you get a very repeat and accurate measurement of the compound you're looking.
Wonderful, Billy. Your explanations are very simple for people to understand, and what I think a lot of my food quality managers, and those are people that are interested in specific metrics of the food, the shape, the color, the size, the freshness, and part of that freshness deals with odor detection. How can the Owlstone's Lone Star Analyzer assist these food quality managers with food freshness and odor detection? How can that be performed?
So I would say food freshness and odor detection is kind of where the key strength of our technique is. If you think about food stuff, there is a smell associated with it. And as food products degrade over time, that odor profile can change. So, for instance, if you looked at meat, for instance, over time you'll tend to form compounds like biogenic amines. And by detecting those types of compounds, you're able to, quite early and quite accurately determine whether or not the foodstuff is actually fresh. So in essence, our instrument is giving it a smell and saying, yes, this falls within your quality bounds for food freshness.
Wonderful, Billy. As we think about the direct application of the Owlstone Lone Star Analyzer, how can the spoilage of meat, which you just mentioned, during storage and transportation be detected?
Yeah, so this is where we've done quite a lot of work. So I mentioned this notion of looking at the odor profile above a sample. One of the things that we have worked on within the industry is trying to say, right, when meat is delivered or when it's in process, how do you effectively look at whether or not it's fresh and the aging of it? So from the bacterial activity within the meat as it matures or goes off, what you will tend to get is gases released. And our technique tends to work very well in situations where the gas of interest has what's called a high proton affinity. And our sensor is able to pick up these gases, these biogenic amines, which are given off as meat degrades, as it starts to rot and churn, and we can get a very low-level measurement and accurate determination of whether or not that meat is fresh. So by specifically targeting those biogenic amine compounds, that we're able to get that measurement.
That's very interesting. Now, just for the information of our audience, goes off is a local term used in the UK for food which has been spoiled and not fit for human consumption. Is that correct?
It is. It is a little bit of the local lingo there.
So high protein affinity, that's a very interesting term.
Proton affinity.
Proton affinity.
Yeah.
Okay, so biogenic amines. Can you explain both of those, high proton affinity, and biogenic amines?
Well, when we look at, so because our instrument can be used in lots of different applications, we will often get requests from people at various stages in food manufacture, whether they're screening for raw ingredients or they're looking at the state of food beverage during the process. Now, where our technology really works is where the compound of interest has what's called a high proton affinity. And basically what that means is whether or not our system is going to be able to sniff it and detect it at very low levels. So, a concrete example would be a biogenic amine given off by meat does have a high proton affinity, which means that we can be pretty sure that our instrument is going to work extremely well there. So when we look at the range of food applications that we've looked at, another example is detection of 4-methylamidazole in caramels used in soy sauce and soft drinks. Because that compound also has a relatively high proton affinity, it means our technology is going to work very well. And where this is valuable both for us and our clients is it means that we can quite quickly tell whether or not the instrument and the technology is going to solve their problem. So that is, obviously we want to supply instrumentation which is of value to the clients, and we can do that screening process by looking at this, what are the compounds that you're interested in and what are the proton affinities that they have.
Excellent, Billy. How can the detection of potato storage diseases be quantified in less than 5 minutes?
So again, the principle is somewhat similar. We're looking for where you have biological activity and you have off-gassing associated with it, so detecting, smelling the rot associated with it. And here, what we tend to do as a company is, we can supply the instrumentation, and that instrumentation can come configured for a particular application, or our partners can develop their own methods for whatever application that they have. So we worked in conjunction with Warwick University and the Potato Council in the UK, who were interested to say, can this technique be used for early stage detection of potato rot? So we supplied the instruments, we trained them up. The and use it both in the lab and in the silo. And the question they were trying to answer is, can you detect that smell of the potato going off? And the results that they published, various journal papers and internal presentations at conferences and stuff, was that you can. There are volatile markers that our instrument can pick up that allow you to get a very rapid screen of whether or not you have rot within your silo.
Interesting. Now, when you use the term rapid, having run mass spectrometry myself and looking at the liquid chromatography, you're looking at 32 steps. Each step is an hour, and then having to interpret the data. What is a rapid detection report of a result with an Owlstone Lone Star analyzer?
Our instrument is exceedingly fast. You can generate the spectra within 1 to 2 seconds or so. So that's the time frame in which you will get your answer. Find is the time is dominated more by how long it takes your sample to get to the end. So in the potato silo example, you would have a pump on the front of the end. It's taking a sample from the silo and pushing it to the instrument. And typically, that might take a minute or 2 minutes, though. But when you look again, as you say, compared to some of the analytical techniques that are used today, you're now looking at minutes as opposed to years or days.
Wonderful. So let me see if I can visualize the system that your company is offering. You provide the instrument, you design the parameters of the analyzer, the positive product ion peaks, as I've read, and the negative product ion peaks, which determines a profile, which then returns a result to the end user. The instrument itself is quite hand portable and hardened. Isn't that correct?
That's right. That's right. Our technology initially we developed for military and security applications. So we won a $5 million contract from U.S. Department of Defense to take our chip and put it into a hardened platform that allows it to be used to detect toxic gases for security applications. Now, the lessons learned there in taking an analytical technique, which is powerful, but putting it into the field for use by non-specialists in a hardened package, is something that we took and applied directly into industrial process control and food and beverage applications. So the instrument that we sell for these applications is called Lone Star. It's very portable, very simple to use, very quick. And as you mentioned, we can supply that instrument configured with methods already. So out of the box, it'll be ready to screen for compounds for your application. Or, some of our larger food and beverage clients, they are working on processes where they don't necessarily want to reveal what contaminants they're looking at, or the evolution of the volatile gases in their products. So we can supply instrumentation and training that allows them to basically configure the instrument for their own application.
Wonderful, Billy. At this point, I'd like to allow you to review our interview. What is the FAIMS technology, Field Asymmetric Ion Mobility Spectrometry? Talk about its sensitivity, specificity, how you supply and equip, and if you don't mind, talk generally about what is the application cost, because quite often in my career in dealing with scientific instrumentation and direct application, at the end of all of that discussion, the manager will look at you and say, Andy, how much is it going to cost me?
Yeah, no, absolutely. Sure, so I'll run through that summary quite quickly. So Owlstone, our company, we make microchip chemical sensors. The underlying technique is called FAIMS, and it's an ion mobility technique. And one of the great things about ion mobility is the inherent sensitivity and specificity of the technique. And what we have done, where our innovation has been, is taken that to a chip, allows you to have a portable instrument, but probably more importantly, it's putting it into a package that allows you to take this instrument from the lab, put it in the field, on the loading dock, on the factory floor. And then the third thing is, designing an interface, both in terms of, the software on the system, and the hardware of the system to make it such that it can be easily used. And this system that can be deployed in fields operated very quickly. Because you program it just in software, it makes it incredibly flexible. So you can take this instrument and configure it to look for biogenic amines in meat which is rotting. You can look at the aggregate odor profile on incoming raw ingredients to make sure it's within spec. You can look for specific compounds in incoming raw ingredients to make sure that's either at the level it should be, or if it's a contaminant, making sure it's not present, or use it directly in process for basically real-time monitoring of the odor profile of your reaction. So incredibly flexible, and we can exploit that by either shipping an instrument pre-configured for the client need, so auditors is what they need, or we can teach the users, the clients, how to do their own method development. So they'll take the instruments and configure it specifically, for their requirements. They can do that because of the flexibility of the technique. So overall, the cost, it does depend on the application and the exact requirement, but you're looking at a standard cost of around $49,000 for the base model.
Can you repeat that? There was a disturbance in our transmission.
It's about the base model itself is $49,000.
So an average consultation for a specific target profile, let's talk about meat. What would that whole entire consultation be with the instrument, the specific, and we're not talking about off the shelf, maybe they're just looking for a specific target gas profile. What would that look like before mobilization?
Well, so there's two options really. So I said if the user, the client, wants to do the method development themselves, in essence they can get the instrument and we will train them at no cost, so they can do that themselves. If they want to get the instrument and program it for an application that we've not done before or is a bit customer bespoke for them, we can do that, and we will typically operate on the basis of, we will be contracted to do that customization work. And there really does depend on, how difficult the problem is, but it would be structured in such a way that there's the cost of the instruments plus the cost of doing the method development itself.
Thank you so much, Billy. As I look through your website, I note that Owlstone has a number of other products. If you don't mind, can you just review a number of those technologies that look particularly interesting?
Yeah, absolutely. So as mentioned, our core business when we first got started in today is defense and security. So that's where we take our microchip spectrometer, put it into platforms for detection of toxic gases, by first responders, military, those types of things. The other main area that we have focused on is where you can actually take our ion mobility chip and use it to extend the capability of your existing mass spectrometer. So if you do have a mass spectrometer and you have a particularly challenging detection application, you can take our chip, put it on the front of the mass spectrometer, and in essence get an extra dimension of separation. So it's a bit like, instead of having an LC or a GC on the front, you can have ion mobility that does very rapid gas phase separation of ion before getting into the mass spectrometer. So that has an extremely broad range of applications, in food and beverage. If you're looking at samples which are, chemically very complex, if you have a high chemical noise background, you can use the FAIMS device to actually filter out the chemical noise in the background to get a much more targeted analysis, lower limits of detection with your mass spectrometer. So it's taking our chip, applying it to existing instrumentation, and in essence allowing you to greatly expand performance and the applicability of that instrumentation.
And you name that the Ultra FAIMS?
That's right. So that's the Ultra FAIMS system. So that sits literally on the capillary inlet of mass spectrometer.
I can see a lot of application for that. What about some of these other instruments, this chemical agent monitor?
Yeah, so they're all within the family of our defense products, where that can be a handheld device that someone can carry around looking for specific compounds. It can be a building monitor application as well. And the nice thing about the building monitor as well is that there's both the defense and industrial applications for that. If you are looking at industrial health and safety, or in process you may be working with a chemical that may be toxic and you want to protect workers, our wall-mounted system can be installed in your facility, and again, because we're just programming what to detect in the software, it can be configured to look for that particular compound that may cause a problem if it was released in the atmosphere in your factory. One of the examples that we worked on a little while ago was detection of diacetyl in the air, which is used in manufacture of various foodstuffs, and it was a condition called popcorn lung. So there, it's industrial health and safety, industrial hygienists are able to take the system and use it on the factory floor, not for process analysis, but for protection of personnel.
Wonderful, Billy. I know it's an early hour out in the UK. I'd like to thank you for your participation today and allow you any concluding remarks, including any commercial messages you might have for our audience of 54,000 food production, food quality, food safety, and food security managers.
Well, thanks for the opportunity to speak today. The one thing I would say is, because our technique is very flexible, if you do have a specific application which currently can't be solved using existing instrumentation, or if you have an application where you do need to have that very rapid in-phase detection, please go along to our website. Just search for Owlstone on Google. You'll find us. Have a look at the types of food and beverage applications in freshness, taint detection, contamination detection, and see whether or not those may fit for you. And if there is a problem that is keeping you up at night, and our technology might be able to help, please do just submit a request for more information on the Owlstone website, and often I personally will follow those up, put you in contact with our technical team, and our technical team can have a discussion to see whether or not the FAIMS technology and our Lone Star Analyzer may be suitable for your application.
Well, Billy, I'd like to outline that in your website, as I'm looking at it, you have the UK office, the England office, and you also have an office in the United States. Anyone outside those two parameters is invited to contact you via the website. Is that correct?
That's right. So we have a UK and US office, and we also have a network of global distributors. So the easiest place to contact us is through the website, and that will get routed to the right person in whatever country you're in.
Well, Billy, thank you again for your time and the most informative interview.
Thank you very much.
I'd like to wish you a great day.
Cheers. Thank you. Bye.